Okay, so at this point we get the gist of argument passing. We know that they go into A0, A1, A2, but let's go ahead and completely overdo it past 10 arguments because we know that only 8 argument registers exist, and after that they have to go on the stack. So let's see exactly where they are put on the stack, how they're put on the stack, and so forth. So this function main calls func with 10 arguments, and then func has a uint64 defined as unsigned long, takes the 10 arguments and just does some math on them. Addition, subtraction, calculates a result and returns that result. So that code generates this assembly, and we're going to pick up a new assembly instruction sub. It's a little bit too big to fit on the screen because we have so many add subtracts. So what does the sub instruction do? Well, what you would expect it to do. Subtracts a register from a register. So that's written in this form, source1, source2. So register source1 minus register source2, the result is placed back into register destination. So if you saw an assembly instruction like this, you would be doing x2 minus x3, storing it back into x1. So sub, like add intentionally, does not have a 2-register form in RV32i. You have to specify all 3 registers. So there's no subtract that implicitly uses the destination as a source. It's always source1 to source2. Okay, well, let's go ahead and take a look at the code, draw a stack diagram, and see what goes where with all of these registers being thrown all around for all these arguments. Stop, look through the assembly, draw a stack diagram. You're used to this at this point, right?